It does say here, solve the simultaneous equations. Now, I haven't been calling it simultaneous equations with you. I've been saying solve the system, okay, system of equations. But another way of saying the system of equations is to solve simultaneous equations. Do you know what the word simultaneous means? Pardon?
At the same time.
Multiple, not multiple. Well, it kind of has to be multiple, more than one, but it does mean at the same time. In sense of this, then, what does the simultaneous mean in context with these two equations? Solve the equations at the same time doesn't really mean that. Okay, because the x and the y are the same for both. Yeah, we must use both of these to solve the problem. So we're not necessarily solving both equations at the same time. We are using both equations to be able to find the x and y that works in both equations. All right, so that's what the simultaneous. But we've been saying system of equations. Now, you know how to do these ones. Now, one thing that isn't on here that was in the textbook that we've been working on is they've not been numbered, but we should probably stick with that process, number 1, number 2. So it keeps a track of what we're doing. So the first step is to number. Okay. So we are going to continue with our elimination method. Our elimination method. So what do we mean by an elimination method here? That would be a substitution method. That was the first method. We need to recap on that because you probably forgot it. What does it mean to use the elimination method? If we use a substitution method, we substitute in. So if we're using elimination method, we are getting rid of numbers. If we look at those two, what are we trying to eliminate and get rid of? In this case, it would be the y. Yeah? Sometimes it could be the x, but we want to get rid of one of the variables. Why did you say y in this case?
Because that's the only one here that we
Why can we eliminate it in this case? What is it about it that says y is the one? You're right, so what is it about it that you know?
The same value in both.
Same value, yeah. We've got 3 y's and 3 y's, yeah? So do you remember we went through the process, we look at that and go, right, the y's are the ones that are the same amount. One's positive and one's negative though, so when we eliminate, we're either adding or subtracting. So what do we do? Add, okay, because they're positive and negative, they're different. So to eliminate a positive number using a negative, you add them together, yeah? You put them together, the positive and the negative cancel each other out, make 0. So if we add them together, I've got to do 4x plus x makes 5x. Positive 3y plus negative 3y is 0, so I can put my plus 0. And then 18 plus 7 is... Okay. Now we don't actually need the plus 0, so I can just say that 5x equals 25. What do we do next? 5, so 5x's, you split those up into individual x's, divide the 25 by those 5x's, and you get, well, each x must be worth 5. Okay? done? What do we do next then? How do you do that? Use one, use two. Which one do you choose? Use one, okay. Doesn't matter. So 4 times 5 is 4x, so x is 5. 4 times 5 plus 3y's equals 18. Why didn't you choose 2, by the way?
I don't know. It seems simpler first.
No, I'd go with it. Y is the one you want to find. This is negative y's. I kind of avoid that if we can. It's not the easiest thing in the world. So we've got 20 plus 3y's equals 18. What do we do now?
I sorted it out in my head. Because what's
Subtract.
20 for everyone?
Subtract 20, yeah. Subtract 20. Remember, if it's on the computer screen, we've got 3y's and 21, so you subtract 20. Subtract 20 from both sides. You get left with just 3y, and we get left with negative 2. Now, sometimes people go, oh, but I must have done something wrong. That's not good. Can't do that, but it's fine. What do we do next? 5 by 3. And we happen to get y is equal to?
0.66 recurring.
Or we just leave it as negative 2 over 3. Negative 0.6 recurring is, it's fine. It's just rounding, isn't it? So I can leave it like that. That's good. All right. So that's just a recap on what we've already been doing. That fine for everyone? Good. Let's go up to the examples then. The next one's in the exercise of the book. All right. I'm just going to rewrite these in the form that we're used to seeing, because it's got solve that and that. So I'm going to rewrite it as equation number 1 is 3x plus y equals 9. And equation number 2 is 5x plus 4y equals 22. Okay. Now, once we've done a little bit more kind of practice with both methods, some of you might go, Mr. Potts, I don't think we should do elimination method here. I think we should do substitution method. Why? Does anyone know why I might suggest that? Well, if you remember substitution method, it was when you had a y equals or an x equals, yeah? So you could replace all the y's with something. And in this case, look, this is, if I just subtracted 3x's, I'd have y equals 9 minus 3x, right? And we could do a substitution method. So this is actually an example where we are going to go through it using elimination method, but when you get efficient with your mathematics and you've got multiple methods that you could use, I'd probably use the other one for this. All right? But we are going to do what they ask us to do, and we're going to use the elimination method, and there is a problem at this stage with the elimination method. Anyone spotted it?
Nothing similar.
Nothing the same. Yeah? There are a different number of x's and there are a different number of y's. We relied with the elimination method on having the same number of x's and y's. Okay? Does anyone already know what we could do at this stage? We have learned something already that helps us. That's why it's in this part. What do you think, Jack? You would subtract them. Subtract y or?
Subtract x.
Subtract x. Subtract each one from each other. I don't get what do you mean?
I'm trying to figure it out.
Alright. So I want to apply equivalence transformation. So I've got x equals 3, then 2x equals 3 plus x. What did I do to each side to get the 2x equals 3 plus x? added x, yeah? And then the 2x equals 6, what did I do for that one instead? I added x for the first bit. Sorry, I need to... Okay, so if we start with x equals 3, I did two different things there. I did 2x equals 3 plus x. So what was the transformation I did? Add x to both sides, right? But if I have 2x equals 6, what did I do? Times by 2, yeah? I did different things. What if I took x equals 3, added x to get 2x equals 3 plus x, and then I multiplied 3 by 4, what would I have?
You would have 8x equals 12 plus 4x.
I would put that. Multiply everything on both sides before, yeah? Do you remember doing that sort of stuff? Have I changed it? Is x still equal to 3? So let's just check. If I do 8 times 3, I get 24. And if I do 12 plus 4 times 3, I get 24. So I'm good, right? Nothing's changing. You with me, understand? Yeah? Now, I'm going to do the same thing here. Let's just recap slightly. What's the problem with my elimination method? Nothing's the same. But I can change one or other so that I do have the same number of x and y by applying some transformations. So which one? So we've got 3x's and 5x's. They could go together, like I know how. But probably the easiest one for this one is to think, well, I've got 1y and I've got 4y's. So what can I do? Could. Which one? First one or second one?
Second.
Could do that. That would work.
The y's would be equal.
The y's would be equal. This would be 1y, wouldn't it? You will see that. Pick the hardest way round. I'm not going to do the divide by 4, but you are 100% correct. We could divide by 4. Why am I choosing not to divide the second one by 4? Well, I could get exactly the same results by doing something a little bit easier. The reason why, what would this be if I divided 3 by 4, Hannah? Do you know? That's important. Would it just become 5x plus y equals 22? How do I know that? Look, here it is. It's wrong. It's not the same. So it'd be 5x plus y equals, and I could just do this 22 divided by, no, it still doesn't work. Divide the whole thing. So it would be 5 divided by 4 and x 4y. That works. Do you all see that? Look how that's just fine, absolutely fine. I'm happy with that. You guys probably not so happy with it, but that works. The principle that Hannah's just told us is exactly right. But I could get there and have easier numbers. So instead of dividing this one by 4, what could I do instead? Well, if I minus 4, look what happens. I minus 4 and minus 4. Fine, that works. But what has it not helped me with? I'm coming to you next, Taylor. Hey? I haven't changed anything, right? This is still 4 y's and 1. If I subtract 4, remember this 4 is not a 4. It's the number of y's. So subtracting 4 will work from both sides, but it doesn't help me. Taylor? Divide by 3. Which one? Divide the top one by 3. Yeah, I could do that. So that would make the top one x plus y divided by 3 equals... Oh, equals what? 3. But, yeah, that is still 2. That works absolutely fine. You're right, same thing as Hannah. I think what you've said is absolutely perfectly. I could now forget about that one and just solve those two. There's still a problem. I still think you're going the hard way. So there is something else we can do instead. All right. How about multiplying instead? I multiply this one, look, what do I get? 12x's plus 4y's equals 36. And look, I still get the same answer. And now I can just forget about that one. And how does that help me? I now can get rid of the y's. Okay, let's have a look at that then. Look at this question that we're going to be doing. Let's follow that approach and let's write it out like we will do if we're doing an assessment. And this is why having it numbered 1 and 2 works. So what did we say we were going to do? Which one? The number 1. So I'm going to do number 1 times 4. So I'm laying that out. So I'm going to do, this helps me in my head to make sure I don't miss anything. Times 4, times 4, times 4. All right? Now, what I'm now going to say is it is up to you entirely, but I really suggest what you do is you rewrite everything. And we say, right, my new number 1 is now 12x plus 4y equals 36. My number 2 is still the same. 5x plus 4y equals 22. And I write that out like that. I rewrite it again. I'm not trying to save any trees at this stage in my career. You can do that at the end. Let's not try and save paper. Rewrite it because all you want to do is be able to sort that out. And having it all mixed up with my old number 1 and my new number 1 and my multiplying and maybe my divide and so on. But now, because I've rewritten it, let's forget about that one. You don't need to cross that out in your notes. I would just leave it. But let's just focus on that one now. What do I do?
You would subtract because the y's are both
Exactly.
positive.
We identify that it's the y's again. And we know they're positive and positive, so we subtract 12. So I'm going to do number 1, subtract number 2, because 12 is bigger than 5, 36 is bigger than 22. Do it that way round is nice. What's 12x minus 5x? 7x. I'm not going to bother with plus 0 anymore. I'm going to move past that stage. Carry on putting if you like, but I think we know we are eliminating the y's. And then 7x is equal to 36 minus 22 is
58.
what?
Wait. Oh, I've gone wrong.
18. Sure?
I added it up for 14.
14. Take the 20 away from 30, you get left with the 10.
I added
Take
it
the
up.
2 away from the 6, you get the 4. So 7x is equal to 14. That's nice, isn't it? Now what do we do?
Divide by 7.
Divide by 7, and we get x equals 2. Okay? Are we finished?
No.
What do we do?
Solve y.
Right, here we've got a situation where we've got a new number 1, we've still got our number 2, but we've still got our old number 1. You can still use the old number 1, if you like. because it's still applicable, it's still the same x and y, we just didn't want to use it for our solving. So which one would you like to use? First one, the old number 1. So let's use number 1, so 3x plus, I'm actually writing it out this time, so I've got 2 ones. Sometimes I renumber it 3, but I'm not going to bother this time. 3x plus 1, I don't know, x is 2, so 3 times 2 plus y is 9. So that's 6 plus y equals 9, which means y equals 3. All happy days. Okay. How do you feel about that? Make sense?
Yeah.
That's why it was super important that we understood the equivalence transformations before. Everyone finished writing that down? So let's have a look at the other questions that you've got. Okay, question 2. Label it 1 and 2. I'm just going to let you do it, but so that we take this in steps, your independence and stages, what would you do to be able to solve this one? Because we've got different x's, different y's. What would you do? Add 1. Well, adding doesn't help because we then don't get the x's and
Well,
y's.
we could either divide or multiply.
Okay.
But it depends.
Don't focus all your efforts on y's all the time. X is also there. What would you do, Ted? Yeah, I'd multiply this one by 5 as well. Why? Because that makes the x's the same. You don't always have to get the y's the same. So I'll let you carry on with that. Let's just go through it, whatever stage you're at. I think we're kind of just lacking a little bit of confidence, that's all at this stage. So my new number 1 is going to be 5x's minus 15y's equals minus 115. Okay. My number 2 is a change. So I've written it like that. And what are we going to do? Add or subtract? Subtract, because the focus, which some of you like, I'm looking at Gordon, this is not, you know, it's taking the shortcuts which leads to those issues. So I'm going to highlight
Where did I
those
shortcut?
because you didn't rewrite the first one, and then they were the other way. So which way round do I want to do it? 1 subtract. I'm going to subtract. Which way round?
Subtract 2 from 1.
Doesn't actually matter, but we do it whatever way works for you. So Gordon says, let's subtract 2 from 1. 1 subtract 2. So 5x's subtract 5x's, 0. Okay? Negative 15 subtract 2.
How did I know what the negative 2?
Negative 17 y's. Okay? Negative 115 subtract 4.
Negative 2. That's where I'm wrong.
We just check. That is positive, yeah. What do we do now? Divide by negative 17. And we get y equals what? Y equals 1? Definitely not.
Negative 100.
Negative 100. Well, it's a negative subtract a negative, or divide by negative, so it's not negative. It must be positive. Definitely not 136, because I can't get 136 17s in 119. 7. Alright? Y is 7. What do we do next? Find x. Find x, we're going to use which one?
The original one.
Use number 1, okay? So we've got x minus 3y equals negative 23. Y is 7, so x minus 3 times 7 should be negative 23. So that's x minus 21 equals negative 22. So what do we do? Add 21 to both sides, so that we know that x equals negative 2. Okay? All good? We get there? Right. So, this one, easy, not easy. In this one, we can't simply multiply one of them to make the x or y the same. Alright? We do have to do exactly like Gordon said. We are going to have to find the lowest common multiple of one of the variables. Okay? It doesn't have to be 20. I could focus on the x's and make the x's the same. Or I could focus on the y's and make the y's the same.
Oh no, I found the lowest for all three. All four.
Oh, well, we don't need to do that. Just want to focus on either x or y. And I, personally, I am just going to go with the y's. They're both positives. Even these ones are all positives. There's no, if there was a positive and a negative one, I might avoid that. But they're all positives. And in this case, what Gordon's saying is, we need to not just multiply one of them, we are actually going to have to multiply both of them and find the lowest common multiple. The lowest common multiple of 2 and 3 is 6. So I'm going to multiply this one by 3 and this one by 2. So now I have new both. So my new number 1, you're right, Aiden, you seem to be a bit distracted at the moment. Right? You want to be writing then as we go, or at least listening? Yeah. Just checking in. So my new number 1 is going to be, well, that times 3, that times 3, that times 3. So it's 12x's plus 6y's equals 30. And my new number 2 is, everything got multiplied by 2, is 10x's plus 6y's equals 24. And now I'm in the situation where I've got my y's the same. And we're good to go from now on. So that's basically covered all the bases at the moment. We will go back and talk about substitution, but I think you're good to have a go to kind of work through these problems. At the end of the sheet, there's like applications of substitutions problems, worded ones that we will need to look at once you've had a bit of practice. But
X equals negative 6.
next lesson, we can just get on straight away. If you fancy having a go out to you for homework, then good. Bring your sheet with you.